Hello students. So today we are going to discuss one very important reaction of aldehydes, ketones and carboxylic acid. And the reaction is aldol condensation. So here the condition is that aldehydes and ketones both can undergo the aldol condensation. So aldehydes or ketones which are having alpha hydrogen atom. So aldehydes and ketones which are having alpha hydrogen, when are treated with dilute alkali like NaOH or KOH, so here condensation occurs, and as a result we obtains a beta hydroxy aldehyde if aldehyde is taken. This beta hydroxy aldehyde is called aldol. Or if ketone is taken, then we will get beta hydroxy ketone. That is, this is also known as ketone. Remember one thing, that this aldol condensation is a reversible reaction. See, suppose our aldehyde taken, it is acetaldehyde. Or you may call it is ethanol. See here, condensation means molecules will combine together. See, I am taking the another molecule of the same acetaldehyde here. This is CH3, C double bond O and H. So when such aldehydes which are having alpha hydrogen, remember what's alpha hydrogen? The adjacent carbon to the functional group, this one is called alpha carbon. This one is called alpha carbon. Adjacent carbon to the functional group, carbonyl group, is alpha carbon. And your this alpha hydrogen is the hydrogen which remains linked over the alpha carbon. And remember, alpha hydrogen is having acidic nature. So alpha hydrogen is acidic in nature. Why it is acidic? It is acidic due to strong electron withdrawing nature of adjacent carbonyl group. See, at the adjacent position there is the CO group, and this one is electron withdrawing. Or we can see that here it is, that is, this one is minus I effect of carbonyl group. So the alpha hydrogen is acidic, and it is due to the withdrawing nature of the adjacent carbonyl group. What will happen? This alpha hydrogen, as it is acidic, it is having tendency to set free in the form of H plus. So under the influence of an alkali, the OH bond electron shifts over the carbon, alpha carbon, so that this alpha hydrogen sets free as H plus, and this carbon will acquire now negative charge. See, and at the same time this anion obtained, this acts as a strong nucleophile. So under the influence of these ions here, electromagnetic effect come into the existence, and the pi electron of this another carbonyl molecule will shift over the oxygen, and as a result here the oxygen will bear negative charge while carbon will bear now positive charge. Now what happens? The alpha, see here, now in between the carbon and oxygen single bond will left, and this oxygen will acquire negative charge while carbon will acquire positive charge. So the H plus sets free from the alpha position of the another carbonyl molecule will form bond with the electronegative oxygen, and then the remaining anion, this one, so negative charge carbon will form bond with the positive charge carbon. See, here this is the functional group. Adjacent carbon is alpha carbon, and the next carbon, this one, it is beta. So in this way we obtain here beta hydroxy aldehyde is obtained. Here the two molecules, they combines together. This one is example of condensation reaction. Although in condensation reaction sometimes some simpler molecule sets free like HCl, like water, like alcohol, like ammonia, but in this end it is not compulsory that always some simpler molecule will set free. As in this case, this no smaller molecules comes out. See, this particular compound beta hydroxyaldehyde is also known as aldol, and that's why the reaction is called aldol condensation. Is not given only by aldehyde. We may take here ketone too. See, let this time this is a ketone, or it is acetone. Here functional group is CO, and adjacent carbon is alpha carbon, and this alpha carbon is having hydrogen, means this is a ketone which is having alpha hydrogen. So either aldehyde or ketone, both, which are having alpha hydrogen, when treated with dilute alkali, so condensation reaction takes place and you will get beta hydroxy aldehyde or ketone. As in this case, see, here it is the another molecule of acetone, and when it is treated with dilute alkali, see, as we know that this alpha hydrogen are acidic. Alpha hydrogen means the hydrogen remains linked with the alpha carbon. So this H is having tendency to come out in the form of H plus. So for the purpose alkali is taken. So under the influence of this alkali, both the electron of this CH bond comes over the carbon, and this H alpha hydrogen sets free as proton H plus. The carbon will acquire negative charge. Now this anion which is obtained here and is a strong nucleophile too. So here electromagnetic effect come into the existence under the influence of these ions. Now as a result here a single bond will left in between the carbon and oxygen, oxygen will acquire negative charge while the carbon of carbonyl group will acquire positive charge. The H plus, which sets free from the alpha position, will form bond with the electronegative oxygen. Now the remaining species is CH2, here C double bond O and CH3. This carbon is negative charged as the 2 electrons are of the CH bond shifted over the carbon. Now this electronegative carbon will form bond with the electropositive carbon. Here again, see, this molecule is, this carbon adjacent to the functional group is alpha, next one is beta. So in this way we obtain beta hydroxy and molecule is ketone. So beta hydroxy ketone is obtained and this one is a ketone. So this is the aldol condensation. Now we will discuss that how the reaction occurs. Remember, the aldol condensation is reversible in nature. Now we will discuss its mechanism. How the reaction occurs. In this case, alkali dissociates and furnishes hydroxide ion. Here it is an aldehyde or ketone which is having alpha hydrogen. See, this one is having alpha hydrogen. Now, under the influence of the OH minus, as we know, these alpha hydrogens, they are acidic in nature. So, the electron pair of this OH bond shifted over the carbon. And this H will come out as H plus, will combine to the OH minus furnished by the alkali and sets free as water. Now the remaining species is CH, as the 2 electron of CH bond comes over this carbon. So this will become negative charged and here it is a C double bond O and H. See, this particular ion is called enolate ion. See, here there is a resonance, the piton shifted over oxygen, and in order to compensate the deficiency of the carbon, these 2 extra electrons shifted in between the 2 carbons. Now here, in between the 2 carbons, double bond is formed and this oxygen, single bond will left now in between the carbon and oxygen. As the 2 electron comes over the oxygen, it will become negative. Again, these electrons may come back and these don't come back. So this is the resonance. This ion is called enolate ion. This enolate ion, this itself acts as a very strong nucleophile. Along with this nucleophile, the Na plus remaining ion are also in the solution. So what happens under the influence of these ions, enolate ions and sodium ion? Here it is the another molecule of aldehyde, and now the enolate ion, which itself acts as a nucleophile, and we know that the carbonyl compounds or aldehydes and ketones, they undergoes nucleophilic addition. See, addition due to presence of the double bond, and nucleophilic because the electropositive carbon is more reactive. That's why. So here, under the influence of these ions, electromagnetic effect will come here in existence. Now, in between the carbon and hydrogen, single bond will left. Single bond will left. And over oxygen, now as the two electrons are shifted, this oxygen will become negative and the carbon will become positive. Here, now this electropositive carbon will form bond with the negatively charged oxygen of the enolithion. See here. And in this way, here we will get a anion is obtained. This anion, then this will abstract a proton from water. As the NaOH taken, it is an aqueous. So water is a medium. So from water, this will abstract a proton. This one is water. So what will happen? The one of the OH bond breaking occurs. Both the electron will set free, will come over the oxygen, and the H plus, which sets free from here, will combine to the negatively bond with the negatively charged oxygen, and we'll get CS3CH here, O, and now H here, C, H, H, and C double bond O, H. We get alpha, beta, beta hydroxy aldehyde is obtained. Means that is aldol is formed, and that's why the reaction is called aldol condensation. See, remember in carbonyl compounds, the CO bond is always is having a polarity. Here the carbon remains partially positive charge, oxygen remains partially negative charge, because there is a large difference in the electronegativities of the carbon and oxygen. See, remember one more thing. So this was the mechanism, and remember one more thing here. The product which is obtained by the condensation in aldol condensation, that is when heated with in presence of dilute acid, so dehydration occurs. See, let our product obtained by the aldol condensation is this. This one is beta hydroxy aldehyde, might be which was obtained by aldol condensation. See, so what happens here? In presence of alkali, this alpha hydrogen loses its electron, sets free as H plus, and now electromagnetic effect comes into the existence. H plus will form bond with the O, you will get OH, and now the negatively charged carbon will form bond with this positively charged carbon, and we will get beta hydroxy aldehyde, this obtained. Now if this product obtained by aldol condensation, it is treated with, is heated and in presence of acid. A dilute acid must be taken here. So what happens? Dehydration occurs. See, still the adjacent carbon to the functional group is alpha carbon, and alpha hydrogen are acidic. We know the hydrogen remains linked with the alpha carbon or alpha hydrogen. Here dehydration occurs, the OH minus comes out, and the electron pair of this alpha CH bond shifted in between the two carbons, and here water molecule is lost and you will get CH3CH here. As the two electrons comes here, double bond will form, and we will get here, there is the unsaturation in between the alpha and beta. So we will get the alpha beta unsaturated aldehyde. If after condensation our product is beta hydroxy ketone, so here we will get the alpha beta unsaturated ketone will be obtained as a end product. Is it clear? Even after that, see, in the two examples we discussed, in that here both the molecules were same. In the first example, both the molecules were of acetaldehyde, while in the second one, both the molecules were of acetone. Okay. But in case the two molecules of aldehydes or ketones which condenses together are different, so in that situation, the reaction is called cross Aldol condensation. Then it is named as cross Aldol condensation. See, let my one molecule, see, both the molecule, different molecules may be aldehyde, both may be ketones, and it is also possible that one molecule is of aldehyde, another molecule is of ketone. See, let it is one molecule is aldehyde, for this one is formaldehyde, and the another molecule is acetaldehyde, and when it is treated with dilute alkali, so what happens here? The alpha hydrogen will come out as H plus. This carbon will become negatively charged. Now electromagnetic effect will come here. Oxygen will acquire negative, carbon will acquire positive. This electropositive carbon hydrogen will form bond with the electronegative oxygen, and electronegative carbon will form bond with this electropositive carbon. We'll get this type of product. See, this is the functional group. Adjacent one is alpha, next one is beta. It is beta hydroxy aldehyde is formed. So this one, as the two molecules which condenses together, these two are different. That's why it is example of cross Aldol. See here, the two molecules taken, both are aldehydes. It is also possible that the two molecules which are going to condense together may be ketone. Let this is acetone, and the another molecule which is going to condense with it is also acetone, and now they are treated with dilute alkali. See, this is the alpha carbon and the hydrogen linked over it are alpha hydrogen. So the two electrons will shift over this. Hydrogen comes out as H plus and carbon will acquire negative charge. Now electromagnetic effect, oxygen will gain negative while carbon will become positive. See, here the CH3C, electronegative oxygen will form bond with the alpha hydrogen which sets free as H plus. Now the positively charged carbon will form bond with the CH2, and here we will get, see, adjacent one is alpha, next one is beta. So we obtain here beta hydroxy ketone this time. It's possible. And this one is also possible, that if we are taking one aldehyde and one ketone, see, let the two compounds taken, it is one is acetone while the another one is acetaldehyde. See, both are having alpha hydrogen. So, and is treated with dilute alkali. So, as both are having alpha hydrogen, so there are number of possibilities that might be the alpha hydrogen sets free from the acetaldehyde. So, in that situation, the product will be CH3C, here OH, CH3, and now CH2, C double bond OH. This one is also possible that the alpha hydrogen sets free from the acetone. So, in that situation, the product will be CH3C, here OH, H. Now, as the one hydrogen comes out, so here the remaining group will be CH2, here C double bond O, CH3. See, in both the cases, this is alpha, this one is beta. We obtain here beta hydroxy aldehyde is obtained if we are removing the hydrogen, alpha hydrogen from aldehyde. In this case, here it is, we will get beta hydroxy ketone is obtained if we are removing the hydrogen from ketone. So, then you will get beta hydroxy ketone. There's another possibility is also there. It is also possible that might be two ketones are condensing together, or might be two aldehydes are condensing together. Then in that situation, so if the two ketones will condense together, so here you will get the product here beta hydroxy ketone is obtained, and might be two aldehydes will condense together. So in that situation, see, this is alpha, this one is beta, we will get beta hydroxy aldehyde. So, in this case, there is the possibility of the formation of 4 products, and all the 4 products will be formed. See, one thing more, remember that this aldol condensation may be intramolecular too. See, sometimes whenever the if two either CHO or CO groups which are lying at 1,6 or 1,7 position to each other in same molecule. In same molecule, if there are two CHO or CO group are there and they are lying at 1,6 or 1,7 position to one another, then with dilute alkali, and that compound which is having two CHO or CO group at 1,6 or 1,7 position to one another is treated with dilute alkali. So here intramolecular aldol condensation. Intramolecular or means aldol condensation occurs but within the same molecule. This takes place. See, we'll try to understand this one using taking one example. Let this is C double bond OH. Here it is CH2, and this is 1, 2. Here it is CH2, 3, then CH2, 4, then CH2, 5, and then CHO, this is 6. See, here the molecule is having 2 CHO group, okay, and they are lying at 1,6 position to one another. See, the name of this compound is, it is hexane 1,6-diol. So this is the molecule. Here there are 2 aldehyde group and they are lying at position 1 and 6 to one another, or 1, 6, 7 maybe, you know. So here what happens? So and this compound is treated with a dilute alkali. So what will happen? See, the adjacent carbon to this one is alpha hydrogen, alpha carbon, and these hydrogens are alpha hydrogen. Same way here. So both the groups are having alpha hydrogen. What will happen? The alpha hydrogen of one of the molecule will set free as H plus, because this one is acidic. Will lose the 2 electrons and this and will set free as the H plus, while the carbon will acquire negative charge. Now under the influence of these ions, electromagnetic effect will occur. This oxygen will become negative charged, and while the partial positive charge acquires over the carbon. Now this negative charge, this positively charged hydrogen, see, this is CH2, here it is CH2, here it is C, and now single bond will left in between the carbon and hydrogen, oxygen. Now the alpha hydrogen sets free from here will form bond with electronegative oxygen, and this electropositive carbon will form bond to the electronegative CH. Okay, from that alpha carbon from where the hydrogen atom was removed, and this one, here it is, there's a CH2, there's a CH2, and at this carbon there is a CH group. So you will get this type of compound. So here the aldol condensation occurs, but within the same molecule. Okay, so the situation is so in intramolecular aldol condensation may also occurs, but in only one condition: if within the same molecule the 2 aldehydic or 2 ketonic group, they are lying at position 1,6 to one another. Because in this situation we will obtain a ring-like structure, and we knows that if the ring is there, so there will be a strain. So larger the size of ring, lesser will be the strain. So in order to minimize the stress, then only at least there should be this aldehydic or ketonic group should lie at 1,6 or 1,7 position. Okay, is it clear?